Hello geometry fans, this is Mr. Miller and it's time for video 1E and we're going to talk about rules for transformations. Let's do it. First I want to talk about the different types of transformations. There are 6 basic different types we're going to discuss. The first is simply a translation. This dog here on the left is the original dog and the whole thing got moved up and to the right here. There was no rotation, no reflection, it simply got moved. The little arrows indicate how it got moved. Every point on the original diagram got moved the same way. So the tip of his tail got moved along this arrow to there. The tip of his ear got moved all the way over to there. And his heel on that paw got moved all the way over to there. Every point in the original image moved the same amount in the same direction. That's a translation. The second kind is a reflection. All right, it looks like something weird going on with the noses here, but this dog was reflected over this line. They're like mirror images. This is the original nose, and it got reflected to the same but distance on the other side. So it's the same distance to the line, but on the other side. And same with his ear here. His ear here got reflected over the line to right there. It's the same distance between those two ears. Okay, so the next type is a rotation. Rotation is where the figure is simply turned. This figure got rotated through an angle up like that. Okay, these 3 transformations we talked about, translations, reflections, and rotations, are called rigid motions because they preserve the size and the shape of the original figure. Okay, the next 3 transformations don't preserve the shape and the size. They affect them. So, all right, so the next one is this. This poor dog got stretched out horizontally. That's a horizontal stretch. And if he got shrunk in, that'd be called a horizontal shrink. All right, this is a vertical stretch. His width here didn't change. What changed was the vertical dimension of it. So that's called a vertical stretch. And finally, the last one is called a dilation. There are 2 examples here. Here's the original image, and here he got made larger, and in here, this one he got made smaller. So a dilation, when a shape is dilated, it has the same shape, but different size. Okay, it's kind of stretched in both directions to get here, and shrunk in both directions to get that one. So those are the 6 basic types. Our other goal in this video is to discuss how to apply rules for transformation, kind of get used to the notation. So here is our original figure. It's a triangle and it has vertices R, S, T. Okay, we're going to apply this transformation to them. Over here, what this XY represents are the coordinates of the old point. And this rule tells me how to get the new point based on those coordinates. So I got to find the coordinates of the old point, apply the rule to it, and I get the coordinates of the new point. All right, so I'm going to start with R. The coordinates of R are 2, 3. Okay, I'm going to apply the rule. The new point I'm going to call R prime. Okay, we use a little tick mark here, prime, to indicate the new point that corresponds to R. Okay. So this is X here, and this is Y. We got to apply the rule. So the first coordinate of the new point is X minus 5. Well, X is 2. So 2 minus 5 is negative 3. And this tells me how to compute the second coordinate of the point, Y minus 1. Well, Y was 3. 3 minus 1 is 2. That's our new point. So R prime is negative 3, 2. It's going to be about right here. So that's R prime. Okay, let me do the other 2. So we have S. The original coordinates of S are 5, 4. And we're going to apply the rule. Remember, this is the old X and this is the old Y. And we're going to get S prime. Okay, the first coordinate is the old X minus 5. So 5 minus 5 is 0. Okay, the second coordinate, the new Y coordinate, is the old Y coordinate minus 1. 4 minus 1 is 3. So 0, 3. 0, 3 is right here. That's going to be our new point S. Okay, let's find t. So the original t was at 3, 1. We're going to apply the rule and get t prime. First coordinate is the old x minus 5. 3 minus 5 is negative 2. The second coordinate is the old y minus 1. 1 minus 1 is 0. So this is at negative 2, 0. That would be right here. Now, this is kind of hard for me to draw. Let me connect them. If we're doing this on paper, we can use a ruler. All right, and we see that this was a translation. It moved it to the left and down a little bit. All right, let's try another example. So here's a different rule and a different triangle. So let's start with, I'll start with S here. I'll go in alphabetical order. So S. The coordinates of S are negative 1, 2. And we want to apply the rule to get S prime. This rule says that the new first coordinate, the new x coordinate, is the same as the old one. So that's easy. I just copy it. The old coordinate was x. The new coordinate's x. The second coordinate says we take the opposite of the old y coordinate, minus y. So minus 2 is the new y coordinate. So S prime, negative 1, negative 2 is right here. That's S prime. Okay, let's find T prime. So T is at 1, 5. And we're going to apply the rule to get T prime. So the new x coordinate is equal to the old one. The new y coordinate is the opposite of the old y coordinate, so it'd be negative 5. So t prime is at 1, negative 5. 1, negative 5 would be right here. And we got one more to go. So u, the original coordinates of u are 3, 5. And apply the rule. U prime would be, well, the first coordinate is the same. And the opposite of the second coordinate would be negative 5. So 3, negative 5. Okay, so that's u prime. So here's that side. Then let me see if I can connect this. That's S prime t. And, this is kind of hard to do. All right, I have a digital pen, but I need a digital ruler. All right, it's a pretty wobbly looking triangle there, but what it should look like is actually a reflection of this one over the x-axis. The key part is we know how to do the rule and plot the points. I know you can take a ruler and plot it. So, all right, that's pretty bad. I'll try to do better. We have one more example. All right, this rule is a little bit more advanced. It gives people trouble, but it's an important rule. The reason why it gives people trouble is because it kind of switches the x and y here, and that bothers people. But if we just kind of follow the rule, we should be okay. So I'm going to write the coordinates of D. The point D is 3, negative 5. So remember, this is x and this is y. All right, first coordinate is the opposite of the y value. The opposite of negative 5 is 5. Okay, the second coordinate is the old x, 3. So basically, these could be anything involving x and y. It's like a formula. And I got to plug the old values of x and y into whatever it is. When I plug the old value of y, negative 5, into here, I get the opposite of negative 5, which is positive 5. All right, let's try E. E is 4, negative 2. Let's see where this goes. So this is x and this is y. And I should call that D prime. So E prime. Let's see what we got. Well, the first coordinate is opposite of y. The opposite of negative 2 is positive 2. And the second coordinate is x. X is 4. All right, and let's do F. So F is at 4, negative 5. So F prime would be, okay, the opposite of y is the opposite of negative 5 is positive 5. The second coordinate is the old x coordinate, which is 4. Now, I'll plot these. I'm going to try again to connect them, but it doesn't work out too well, probably. So this is D prime, and E prime is at 2, 4. This is E prime, and F prime is at 5, 4. 5, 4, right here. Yeah, that's right. So F prime. So this goes over like this. This goes down like that. And I gotta connect these two. So a little bit better than last time. Okay, so I just made it worse. I can't shade it in. Alright, so that's the new triangle. Now, what I want you to see is that's actually a rotation. If you turn this triangle, if we kind of turn the paper this way about the origin 90 degrees, this whole figure would turn and be sideways like that. All right, the main point is understanding how to apply a rule. If I give you a rule, you should be able to take the old points and find the new points. All right, so here's the general assignment. So we just got one thing to do. We got to find the 3 new points. So here are the original points. I would write down the original points like I did, and then show me what the new points will be when we apply the transformation. So we're going to apply this transformation. It says x minus 4, so you're going to subtract 4 from the old x coordinate, and y minus 5. You're going to subtract 5 from the old y coordinate and get the new points. So all you got to do is find h prime, I prime, and g prime. You don't have to graph it. All right, take care. See you in class.